Hey guys, Mrs. Traver here. Today we're going to continue talking about proofs. Our learning target is you'll be able to communicate a logical argument that proves rectangles are also parallelograms, as well as identify different quadrilaterals. Let's jump in. We'll do 3 proofs today. The first one says we are given this parallelogram, ABCD, and we're going to prove that opposite angles are congruent. That's a property of parallelograms, but seeing how we're proving it, it means we don't know it yet. Let me get my pen going here. Sometimes it likes to be a little bit finicky to start. There it goes. All right, let's see. So since the parallelogram, I know that I have opposite sides are parallel, so I could use that. And if I'm going to consider these 2 sides, then I can tell that their opposite angles are congruent because they're alternate interior angles. That'll be my first couple steps. And then I can do the same thing with the other sides. So that would be able to tell me that these sets of angles are also congruent. So that's kind of my mindset. Let's jump in and start our proof by using the fact that we have a parallelogram first. And let's use sides AD and BC first. So AD is parallel to BC is how we can write it. And I'm going to do a 2-column proof this time. So actually, let's mix it up. Let's do paragraph proof. So I'll say AD is congruent to BC. And I'm just going to make it be a sentence instead of having the other side be the reason. So I can say because of the definition of a parallelogram. All right, so there's my first bit. And now that I've shown that it's a parallelogram and those sides are parallel, so I'm going to mark what I've shown so far, I can now tell that these alternate interior angles are congruent. So I can say the measure of angle DAB, so angle DAB is congruent to BCD. Because they are alternate interior angles. All right, so we've got our first set of opposite angles congruent. Basically, I'm going to repeat this sentence, these 2 sentences, but I'll do the other set. So I'm going to say AB is parallel to DC because of the definition of a parallelogram. And then I can say that these 2 angles are congruent. So I'll say angle ABC is congruent to angle ADC because sometimes I write B/C to save myself because they are alternate interior angles. When we write paragraph proofs, there's something special we do to end our proof and to show we're completed is we draw a square and then we color it in. This is something that's been done for a really long time, back to like literally thousands of years ago when students were writing proofs. Like Euclid, for example, he is considered the father of geometry, just a little bit of knowledge there. But when he wrote proofs in his book, The Elements, he would always do this, and it kind of caught on after that. It was his way in his notebook of showing that he was done with that thought process and moving on. So we basically just color in a square to show we're done. Let's do another one. This one says, given rhombus ABCD, prove that triangle BAD is congruent to triangle BCD. So notice that they gave us the line BD that is a diagonal. And I know some stuff about a rhombus. I know that all the sides are equal to each other. So I'll be able to show that this is side, side, side congruent, seeing how I know all of these sides are equal, and then I can prove that BD is congruent to itself. So I think I'll be able to show side, side, side pretty easily. So let's first start ourselves off with just saying all these sides are equal. So I'm going to start with AB is congruent to BC, which is also congruent to CD, which is also congruent to AD. I'm going to say B/C. So because of the definition of a rhombus, all right, and then my last thing I need is to say BD is congruent to itself. BD is congruent to BD, and that is because of the reflexive property. All right, so at this point, I know these 2 triangles are congruent, so I'm going to jump right to my final statement, which is triangle BAD is congruent to triangle BCD. by the side congruence property. And I'm done. So here comes my square that I color in to show I'm complete. We have one more. Here it is, another rhombus. It says, given rhombus ABCD, prove that BX is congruent to XD. So I'm trying to prove this. And what I could maybe do is pick on two of the triangles. I've really got several triangles within here, but I think that I'm gonna I'll pick the ones on the left. So I'm gonna pick these two triangles, and I'm gonna kind of ignore the right half of the figure. I don't need it. But if I can show these two triangles are congruent, then those two sides of them must be congruent because of CPCTC. So let's show these are congruent. Let me figure out a game plan. One of the things I could use is the fact that, actually let me get rid of that too, the fact that we have perpendicular bisectors here. That is a definition of rhombus, so I could use that, as well as the fact that these two are equal, and then I've got a side that's in common, so it looks like I can show hypotenuse leg congruency. So that's my game plan. Let's jump in using the fact that we were given a rhombus first. I'm going to use BA and AD being congruent because it was the definition of a rhombus. Let's do a 2-column this time. We'll switch it up. So that was the definition of a rhombus that we were given, and then so there was a side, that was the hypotenuse, by the way, and then AX is congruent to itself. There's the reflexive property. And then I also want to show that this is a right angle. So angle AXB, I'll say measure of angle AXB equals the measure of angle AXD. And those are equal to 90 degrees. And this is the definition of a rhombus again, because it has perpendicular diagonals. All right, at this point, I think I have everything to say that these two triangles are congruent. So I've got triangle AXB, which is congruent to triangle AXD, because we could either say RHS or hypotenuse leg. Either is fine. Now that they're congruent, I know that all congruent parts of triangles are congruent. So congruent parts of congruent triangles are congruent. And here's my last statement, BX is congruent to XD. Let me fix my little lines and we're done. All right, we've kind of wrapped up proofs here. Hopefully you're feeling confident in how to piece these together. We will continue to do more practice on them as we move forward, and I will see you next time. Bye guys.